Hey everybody, welcome to the channel. SoarKraft has a new 1.6 meter 3D printable glider, the Stretch, available now on the SoarKraft website. We'll look at design specs and a couple examples of build configurations as an introduction to this new airframe. Nice. Thanks for watching. Please like and subscribe. And check out our website for this model and others, as well as printing configurations for different materials. So you may notice that the Stretch resembles the Pica, which I have done several videos for, is really fun to fly, and is also available on the SoarKraft website. The new model is not a scaled up Pica. It's stretched out. Every length is extended. Longer wing, longer fuse, and lengthened tail fins. A high aspect ratio Pica. The wingspan a full 14 inches longer and 3.5 inches longer on the fuse. The wing is based on the current SoarKraft CAD slicer design, with an emphasis on a continuous skin extrusion and a D-box support structure with integrated control surfaces, but in a new layout, using a bit more carbon, including this 8mm square carbon spar, which is removable in this two-piece wing design. Even with this long, skinny wing, this structure maintains the high level of stiffness for the performance I require of my airframes. The first Stretch airfoil available is the MH32, having good speed and lift characteristics, and uses 4 servos with inboard flaps. The flaps hinge on the bottom and have an integrated seam cover. This seam cover is something that I developed for the DS wing with good results. It prints well in most materials, even in the foaming lightweights, though it might need a little knife work to free up the gaps. With a little cleanup and silicone on the hinge line, I really like the results and I will continue to refine it. The fuselage is longer but builds the same way as the Pica and uses some of the same parts, like the wing saddle, tail section, and removable nose cone, but has a longer tail boom and a front extender for better aerodynamic and weight balance, and more room inside. This also makes it compatible with the other available fuselage options. Lastly, the tail fins are longer by 20mm for a full 200mm length each. This and the increased boom length gives adequate control for the longer wing. Control surface push rod connections remain the same as the Pica. Just like my other designs, the part count is low, and I maximize part height to get this extended form. This reduces print and build time, and I really like the final results. So this is the Stretch, and here is the spec list. With the speed and quality of the new generation 3D printers, larger models are more realistic to print now, and the material is getting better and stronger and is still reasonably priced. I can set up the full airframe to print, in this case by the different colors, using the SoarKraft settings in PrusaSlicer on an X1C printer, and get all of the printed parts in PLA Pro in 22.5 hours, and only uses about 600 grams of filament for the whole thing. The foaming lightweight materials still need to be printed one part at a time, but the new gen printer capabilities and low part count keeps this hassle to a minimum. And yes, you can still use older printers for this, and can absolutely make a nice flying airframe. But expect longer print times and more cleanup. Here's a list of the protruted carbon required for the airframe. This information is on the included materials list and in the detailed instructions for the fuselage and the wing. There are several suppliers with these sizes of pultruded carbon. Windcatcher RC has everything in stock and even has bulk pricing. Aloft Hobbies is also a good source. There's even solid square rod available. Material is available worldwide. Just do a search for Pultruded Carbon 1000 and look through the results for what you need. Shipping is usually the biggest expense, so getting everything from one place helps. From there, it uses the same servos and components and builds the same way. Even when using the power pod, the same parts are used. I have complete build videos coming, but refer to the detailed instructions in the meantime. Here is a pair of slope builds. The red is all PLA, and the orange is Prefoamed Polymaker and a PLA fuselage. The orange build comes in at 670 grams, which does well in medium to light conditions. The red one with a solid square spar comes in at just over 800 grams. Which is good for stronger winds and better wind penetration. And as conditions change, I can switch around parts. And the RG15 version of this wing is almost ready. The next example is this stretch with the power pod option in the foaming lightweight PLA, specifically Bambu PLA Aero, with the same lightweight power pod system as the Igneous and Roughgen videos, and even the 3D printed folding prop. This exact model weighs in at 563 grams. Even with this relatively weak power system, the stretch gained altitude pretty fast and was still relatively easy to see. The stiffness of the wing really shines at higher speeds. Good energy retention. And when it came time to land, it behaved nicely. Nice. I hope you like the stretch. Let me know in the comments below. More complete build and fly videos for the stretch coming soon. All files available at SoarKraft.com. And more build options coming soon. So please like and subscribe. Thanks for watching, and see you next time.